How to find the equation of a tangent line. Unlike a straight line, a curve's slope constantly changes as you move along the graph. Calculus introduces students to the idea that each point on this graph could be described with a slope, or an instantaneous rate of change. The tangent line is a straight line with that slope, passing through that exact point on the graph. To find the equation for the tangent, you'll need to know how to take the derivative of the original equation. Method 1. Finding the equation of a tangent line. 1. Sketch the function and tangent line, recommended. A graph makes it easier to follow the problem and check whether the answer makes sense. Sketch the function on a piece of graph paper, using a graphing calculator as a reference if necessary. Sketch the tangent line going through the given point. Remember, the tangent line runs through that point and has the same slope as the graph at that point. Example 1. Sketch the graph of the parabola f(x) equals 0.5x2 plus 3x minus 1, displaystyle f(x) equals 0.5x caret 2 plus 3x, 1. Draw the tangent going through point 6, 1. You don't know the tangent's equation yet, but you can already tell that its slope is negative, and that its y-intercept is negative, well below the parabola vertex with y value, 5.5. If your final answer doesn't match these details, you'll know to check your work for mistakes. 2. Take the first derivative to find the equation for the slope of the tangent line. For function f(x), the first derivative f(x) represents the equation for the slope of the tangent line at any point on f(x). There are many ways to take derivatives. Here's a simple example using the power rule. Example 1, cont. The graph is described by the function f(x) equals 0.5x2 plus 3x minus 1, displaystyle f(x) equals 0.5x caret 2 plus 3x, 1. Recall the power rule when taking derivatives. d dxxn equals nxn minus 1, displaystyle frac d dx x caret n equals nx caret n1. The function's first derivative equals f(x) equals 2, 0.5 x plus 3, 0.f(x) equals x plus 3. Plug any value of for x into this equation, and the result will be the slope of the line tangent to f(x) at the point where x equals a. 3. Enter the x value of the point you're investigating. Read the problem to discover the coordinates of the point for which you're finding the tangent line. Enter the x-coordinate of this point into f(x). The output is the slope of the tangent line at this point. Example 1, cont. The point mentioned in the problem is 6, 1. Use the x-coordinate 6 as the input for f(x). f(6) equals 6 plus 3 equals 3. The slope of the tangent line is 3. 4. Write the tangent line equation in point-slope form. The point-slope form of a linear equation is y minus y1 equals m x minus x1, displaystyle y underscore 1 equals m x underscore 1, where m is the slope and x1, y1, displaystyle x underscore 1, y underscore 1, is a point on the line. You now have all the information you need to write the tangent line's equation in this form. Example 1, cont. Y minus y1 equals m x minus x1, displaystyle y underscore 1 equals m x underscore 1. The slope of the line is 3, so y minus y1 equals minus 3, x minus x1, displaystyle y underscore 1 equals 3, x underscore 1. The tangent line passes through 6, 1, so the final equation is y minus 1 equals minus 3, x minus 6, display style y, 1 equals 3, x, 6, simplify to y plus 1 equals minus 3x minus 18, display style y plus 1 equals 3x 18, y equals minus 3x minus 19, display style y equals 3x, 19. 5. Confirm the equation on your graph. If you have a graphing calculator, graph the original function and the tangent line to check that you have the correct answer. If working on paper, refer to your earlier graph to make sure there are no glaring mistakes in your answer. Example 1, Cont. The initial sketch showed that the slope of the tangent line was negative, and the y-intercept was well below 5.5. The tangent line equation we found is y equals 3x, 19 in slope-intercept form, meaning 3 is the slope and 19 is the y-intercept. Both of these attributes match the initial predictions. 6. Try a more difficult problem. Race a run through of the whole process again. This time, the goal is to find the line tangent to f, x equals x3 plus 2x2 plus 5x plus 1, display style f, x equals x caret 3 plus 2x caret 2 plus 5x plus 1, at x equals 2. Using the power rule, the first derivative f, x equals 3x2 plus 4x plus 5, display style f, x equals 3x caret 2 plus 4x plus 5. This function will tell us the slope of the tangent. Since x equals 2, find f, 2 equals 3, 2 plus 4, 2 plus 5 equals 25, display style f, 2 equals 3, 2 caret 2 plus 4, 2 plus 5 equals 25. This is the slope at x equals 2. Notice we do not have a point this time, only an x coordinate. To find the y coordinate, plug x equals 2 into the initial function, f, 2 equals 23 plus 2, 2 plus 5, 2 plus 1 equals 27, display style f, 2 equals 2 caret 3 plus 2, 2 caret 2 plus 5, 2 plus 1 equals 27. The point is 2, 27. Write the tangent line equation in point-slope form, y minus y1 equals m x minus x1, display style y underscore 1 equals m x underscore 1, y minus 27 equals 25, x minus 2, display style y, 27 equals 25, x, 2, if required, simplify to y equals 25x, 23. Method 2 solving related problems. 1. Find the extreme points on a graph. These are points where the graph reaches a local maximum, a point higher than the points on either side, or local minimum, lower than the points on either side. The tangent line always has a slope of 0 at these points, a horizontal line, but a 0 slope alone does not guarantee an extreme point. Race how to find them. Take the first derivative of the function to get f, x, the equation for the tangent's slope. Solve for f, x equals 0 to find possible extreme points. Take the second derivative to get f, x, the equation that tells you how quickly the tangent slope is changing. For each possible extreme point, plug the x coordinate into f, x. If f, a, is positive, there is a local minimum at a. If f, a, is negative, there is a local maximum. If f, a, is 0, there is an inflection point, not an extreme point. If there is a maximum or minimum at a, find f, a, to get the y coordinate. 2. Find the equation of the normal. The normal to a curve at a particular point passes through that point, but has a slope perpendicular to a tangent. To find the equation for the normal, take advantage of the fact that slope of tangent, slope of normal, equals 1 when they both pass through the same point on the graph. In other words, Find f, x, the slope of the tangent line. If the point is at x equals a, find f, a, to find the slope of the tangent at that point. Calculate -1 f, a, frac 1 f, a, to find the slope of the normal. Write the normal equation in slope, point form. Tips. If necessary, start by rewriting the initial equation in standard form f, x, equals, or y equals.